Hello guys. In this video I wanted to show how to implement an open world navigation system in an existing project. So what I've done is when we go to new project, third person, we have this variant option here. We could choose any of these. I've chosen the combat variant and I already have a project down here using the combat variant. So you get this folder with all these blueprints and other stuff like animations and stuff with the combat variant. I could show the level actually you can play with the combat variant. So this is all Unreal Engine, the combat variant template. So we get thrown into a arena, could fight and do all this stuff. Let me just, yep, kill this guy. Okay, so that comes with a combat variant template or example project. So I've made my own level. I want to show how you can just implement OWNS in the with the combat variant template, the yeah, project. So this is the state tree that comes with a combat variant. So we got all these move to tasks that the AI uses. So let's first use that state tree that comes with the combat variant. Okay, so we are basically using that right now, and as you can see, the AI cannot get to us because there's no nav mesh under us. The AI is using invokers. For a large map, you'd be using invokers, so that's why I'm showing it with the with invokers. So it can't get to us because there's no nav mesh. But we use the OWNS version. Just show that first. What I've done is this is the default one, default state tree, and this is the modified one with OWNS tasks. So basically, you can see in the default one it has move to. What I've done here is I've disabled the move to task and added my own OWNS move to task. Yeah, it's the same thing as a hierarchical request option here as well, but we don't need that for this. So here we use the OWNS move to here also and also here, and the other ones are all disabled. So if we use it like this, you'll see that the AI can now get to us. So in giant worlds, can still get to us. Could go anywhere you want. So he's moving towards us. This green thing is the path it's taking. I'm using the gameplay debugger, and now it's using the nav mesh because it can. It's more detailed, so it's better for it to use a nav mesh. So yeah, now they could get to us. I've paused the game. Select the player character. Could move it away and unpause, and it will still come towards us. Right. So that is how easy it is to implement in your existing AI. And what I also want to show is, so this is the combat AI class, the one that comes with the combat variant template, and these are all Unreal Engine stuff that comes with it with the template. This is the OWNS agent interface function on transition to proxy. What I first do is I set visibility off basically, so we don't see the health bar of the character when it's in status. We don't want to see it on our screen. And what I do is I go to my proxy and I set the owner. So now knows, before begin play, it now knows who the owning agent is, what to reference. And here what I do is I get the state. Let me first explain setting the state. So also here I've created a state tree task, set state. What this does is it sets the state on the agent here. So this is the struct. Let me just show it here quickly. State and target actor. Because we can't access the state tree variables, anything from outside to know what state it's at, right? The state tree when it's about to be put into status. So I've set the task here. Should be around attacking. Oh wait, there's a default one. Yeah, LODNS. Attacking p set state to attacking. Here, and I also set it when it's dead, because if it's died and it gets put into status, we don't want the proxy to do anything. It's gonna know it's dead and it's just gonna wait until it gets deleted. So here I set it dead. The state is dead. The target is player character. Same here. Target is player character. And it gets the combat AI enemy, BP combat AI enemy, BP combat enemy, and it sets the state here. And then when we get put into status and the proxy is alive, you can access the owning agent, access the information that we just set before the agent got put into status. And then I switch on the state. So if it was attacking, we want to go to the player character, because when it gets close to it, it's going to load in anyways, because it's a streaming source. It's going to get restart from status, and then the state tree will start evaluating again and it will attack. In your game, you could even add more states. You can even add a state tree to your proxy and basically have your proxy do whatever you want it to do in the state tree. So I want to show right now. So let's go to our player start. Where's player start? Okay, right here. Let's get a bit far away. And so what's going to happen is it's going to get loaded in, and it's going to want to attack. The state is going to get set. Then it's going to get put into status because it's far away from any streaming sources, if we are far away enough. Okay, so it got put into status, and now the proxy, where's that proxy at? Is, see the coordinates are changing, it's coming towards us, right? And then when it gets close enough, it's going to load in, and then the state tree on the agent is going to start working. This state tree is going to start working, and it's going to keep on attacking us. As you can see, it's coming to attack us. Yeah, I can speed that up. Yeah. So let me just speed him up. Let's go. So that is how easy it is to implement OWNS into your existing projects. There's a lot of stuff you could do. You could increase the amount of variables you want to save from the state tree. You might have more states. basically that is about it. And I also want to say is, if you're using behavior trees, you can access Blackboard keys. It's not like state trees. You can access them Blackboard keys, so you wouldn't have to do these set states and stuff just on before it gets the controller gets destroyed, and the behavior tree and Blackboard with it. You can get your controller, get a Blackboard component, and then whatever properties you want to save, you could save it into your wherever you want to save actually, yeah. So we could just save it like yeah, do something like this, and yeah, basically it's saved then. Then you could access this from your proxy by going to owning agent, state, get current state, and then you can switch on that as well. Or like I said, you could use it in a state tree or however you want to use it. That's all up to you. So yeah, that's it. I will try to build on this project and show different examples of use cases and stuff. Maybe in the next video I'll make a state tree that the proxy could use and decide what to do on its own. So yeah, so for today that's it, and I will see you in the next tutorial example.